Halala right now. So on today's session, Organic Chemists, we want, of course, to reintroduce ourselves to the concept of organic chemistry reactions. And of course, we are not only going to talk about the reactions, but we are also going to talk about reaction mechanisms. But before we can even continue, of course, with that, let us recall or remind ourselves of what is it that we have to know according to the physical sciences examination under the physical properties of organic compounds. We remember we've started by classifying, and now we went to physical properties. So we are saying then, for a given example, remember from classification of these organic compounds, we had to know functional groups, structural groups, all those things. And now, as we know and understand all those things in mfanabosso, it means then we will be able then to try to explain the physical properties of that particular organic compound. Mfanabosso. Halala right now. We say then, let us explain the relationship between the physical properties and the strength of the intermolecular forces. We know that some organic compounds, of course, they have stronger intermolecular forces than others. For instance, those that consist of hydrogen bonds. So for those that consist of hydrogen bonds, of course, they have relatively stronger intermolecular forces, and what you'll recognize and realize about them is that they have greater boiling points. For example, if you were to compare, of course, an alkane versus an alcohol, so you'll recognize and realize that in actual fact the alcohol has a hydrogen bond. So since then it has a hydrogen bond, it means that it has greater intermolecular forces. Mfanabosso. Halala right now. So of course, let us understand then the strength of the intermolecular forces to understand that, well, hydrogen bonds are stronger than dipole-dipole forces, and the dipole-dipole forces are perhaps stronger than the induced dipole forces. So this is just what is happening there, mfanabosso. Let's understand the intermolecular forces of a specific functional group or organic compound, then compare it to others, and of course talk about its strength of intermolecular forces. And of course, the type of intermolecular forces are influenced by the functional group. To say, what functional group do we have then? So since we said, okay, the functional group here, of course, is the alcohol. For the alcohols, of course, OH is the functional group. So since the alcohol then is the functional group, or the hydroxyl is the functional group, we then say, well, those type of intermolecular forces, they have hydrogen bonds, therefore they have greater or stronger intermolecular forces. The other thing then that we talk often about is the issue around the chain length. For instance, we would be comparing alkanes there, and among those alkanes we will be saying, well, try to see the boiling points, try to tell us about the differences in terms of the boiling points. You will be doing that, of course, in relation to nothing else but the chain length. You have to understand that the more we add the carbon, meaning the more we increase the chain length, of course, the stronger the intermolecular forces. Why? Because we have introduced a greater surface area. Halala right now. My name is Mr. Mojaki. They call me Mr. Mfanabosso. Now, of course, then for the chain length, we may also talk about the branched chains. We will realize something that, well, we can have a longer chain and then we can have a relatively shorter chain as a result of being branched. So what is the influence then of introducing the methyls, the ethyls? Meaning, what is the influence to the boiling point, for instance, of introducing substituents, introducing branches? What influence does it have perhaps on boiling point? Halala right now. So I believe that it is a necessity for me, of course, to expose you to as many questions as possible that were asked to some previous learners who were doing metric. So the questions, of course, were asked and the learners were sweating. That's one thing for sure. I saw spaces, I was there. I'm lying, mfanabosso. Mfanabosso. So now the boiling points of some organic compounds are shown in the table below. And they've given you the atmospheric pressure of 101.3 kilopascal. I believe that you have an understanding of what exactly is this 101.3 kilopascal, which of course is what we refer to as a standard temperature and pressure. Taba, mfanabosso, STP. Now let's see the different organic compounds that we are given and what questions is asked, of course, of these different compounds. Now here are the compounds. Let's try to explore them a little bit. The questions, of course, I believe you have the capacity to do it by yourself. So this is a preparation for the preliminary examinations and of course the final examinations. Now here we are given a halogen. So we are given a halogen here. For A, it's a halogen. For B, we also have a halogen. But now this halogen, it seems like it's branched. Remember the physical sciences examination guideline, the holy Bible of physical sciences, mfanabosso, mentioned to say that you must know what is the influence of having a branch, a substituent in your organic compound. Halalaaaa right now. So here we are having an alcohol, and we know that with an alcohol there is what we call a hydrogen bond. So this one, in terms of boiling point, we expect it to have a greater boiling point. Why? Because of the presence of the hydrogen bond. And look at its boiling point, 118 degrees Celsius, greater than water's boiling point. So here we have the carbonyl group. The presence of the carbonyl means that we may be having an aldehyde or we may be having a ketone. So chemistry is fun. The study of composition of matter, the study of structure of matter at a microscopic level, and symbolic level, mfanabosso. So you are given these different organic compounds with different functional groups. So perhaps drawing their structural formulae may help you a lot in terms of the analysis, the interpretation of these organic compounds. Now let's try to see then the type of questions that they'll ask with what they've given us. Define the term boiling point. I told you in the previous video that I've never seen an examination without the question define the term boiling point. It's always a free 2 marks. Now they say which one of the compounds A, B or C is mainly liquid at phase 100 degrees Celsius, which one is a liquid. So of course you'll go there to those organic compounds and try to see them, explore them, and of course answer the question. So you'll look at A, you'll look at B, you'll look at C, and you'll ask yourself which one is a liquid at 100 degrees Celsius. And of course I do believe that, well, it definitely would be alcohol. So alcohol will be a liquid at 100 degrees Celsius since it boils around 118 degrees Celsius. Mfanabosso. Halalaaaa right now. So let us go, of course, and see what other questions they ask. They say explain the difference in boiling points of compounds A and B. You'll go and explore A and B. So I just want to expose you, of course, to the questions that they ask here. Read question 3.4. You can pause the video and go through the questions, and please try these questions so that you'll be ready for your preliminary examination. You'll be ready for your final examination. So this is your one and only chance. Take care of it. Now I'm interested in the last question, the 3.5. Let's see what type of question they ask. They say the atmospheric pressure is now changed to 83 kilopascals. Now there is a relationship that Gay-Lussac speaks of, that, well, a temperature is directly proportional to pressure. It is Gay-Lussac's law of gases and things like that. So when we increase the temperature, we must expect an increase also in the pressure. But in this case, what we've done is that we have decreased the temperature, or rather we have decreased the pressure from 101.3, which was standard temperature and pressure, to 83 kilopascals. So therefore, we also expect the temperature to decrease. So the solution there will definitely be decreased. So mfanabosso, there are many other questions that they can ask here about the physical properties. Please make sure you don't go to that physical examination without reading the physical sciences examination guidelines. Taba mfanabosso. Halala right now. Now let us of course go and explore now the reactions and reaction mechanisms. I couldn't wait. Now it's time. Taba mfanabosso, we are becoming adults. Let us have a conversation. We are talking about reactions. It's gonna be fun. Taba. Now let us first perhaps try to explore what are we talking about when we talk about chemical reactions, for that matter, or reactions. So here is a nice concept that we talk often about in chemistry, and it is called reactions. Now what I want you to understand from this concept of reactions is the fact that for a reaction to be possible, we must have reactants, of course, reacting under particular conditions, of course. So these reactants, of course, resulting to particular products. So that is what we understand as chemists then for reactions. This is a reaction because we have reactants giving us particular products. Now, I want us to explore something now in terms of these reactions. There are three major reactions that we are going to talk of and about. Let's see what are they. Addition, elimination, and substitution. So those are the three major reaction types that we are going to talk of and about. But under addition, there are quite a lot of sub reactions, or whatever they call them, and even with elimination, same mfanabosso. So it is things like that. So let us take them one at a time, and we will understand as to what are addition reactions, what are elimination reactions, what are substitution reactions, and try then to combine these in examination type questions. So that is what we are going to do, of course, in the series of videos that I'm going to upload from now on going forward. Taba mfanabosso. But briefly, for addition reactions, I hope you still recall the terminology that we've used in organic chemistry so far, such as saturated, unsaturated, things like that. Those are going to play critical role then in your understanding perhaps of the addition, elimination, and substitution reaction. For instance, for us to have addition reaction, we have an acronym or whatever we use, of course, to try to remember addition reactions, because we have quite a lot in our minds and we are too young. So we definitely have to have some strategies that we can, of course, use to recall some basic things. Taba mfanabosso. Now for addition reactions, we say for reactants, we are going to have an unsaturated reactant. So that is what is happening here. An unsaturated reactant, and that unsaturated reactant is going to end up with what? Is going to end up with a saturated product. Remember, we said on the left hand side we have the reactants here, and then on the right hand side we have the products. So if ever we see a double bond or perhaps a triple bond, we will know for sure that that is an unsaturated hydrocarbon. Specifically when the double bond or the triple bond, of course, is between carbon and carbon. It's between the carbon atoms. That's the only exception that we will talk about unsaturated hydrocarbons mfanabosso. Taba halala right now. So we are saying that we start with an unsaturated hydrocarbon and we end up with a saturated carbon, and that gives us addition reactions. So USA, unsaturated, saturated, addition reaction. For the elimination reaction, we say, well, we start with a saturated reactant and we end up with an unsaturated product. So definitely that is elimination. It comes to an acronym which we will call SU. And then for substitution, then we say, well, this is the situation whereby we start with a saturated reactant, we end up with a saturated reactant, and that will be or rather we end up with a saturated product, so that will be a substitution reaction. Perhaps that might sound like I'm speaking Chinese. It's fine. We will try to explore these individually and thoroughly so, to say what is even an unsaturated reactant, explore that in terms of equations, as that is what we have to know according to the examination guidelines. Mfanabosso. So USA, SU, SSS, definitely those will help us to recall as to what type of reactions we are having in our eyes when we are given to interpret Gyota. So in the next session, mfanabosso, we will try, of course, to explore each and every one of these reaction types, and of course try to explore the type of examination questions that they ask. Taba. This is a topic whereby most learners have a bit of difficulty on the question around reactions and reaction mechanisms. So we have to take it one step at a time and make sure that we get all these marks under this topic. So please be with me. Thank you very much for watching the video. Do not forget to subscribe, hit that notification bell, and of course share and like, things like that. It costs you 0 cents. Halalaaaa right now. Welcome to Science Intellect Hub.